Hello everyone, today we're going to discuss factorizing, chapter or paragraph 7.2. But to do this, we need information from paragraph 7.1, particularly the part about prime factors. I'm going to warn you a bit. In this and the next paragraph you will think, what and why are we doing this? Because it at first glance seems quite counterintuitive. That's why I show you this slide again. We are going to learn about factorizing because it's going to help us solve certain forms of quadratic equations. So bear with me if you find this strange or weird to do. It will all come together at the end of this chapter, okay? Or as Ned Stark said it in Game of Thrones, factorizing is coming, so please brace yourself. Hey, we're going to take a look. Let's say we're asking you this question. Write in as many factors as possible. And remember, in factors in this case we mean use prime factors, which are discussed in 7.1. So for example, this number here, 24a squared b, can be written as 2 times 2 times 2 times 3, because that are the prime factors of 24, times a, because a squared means a times a, and then we're left with times b. So for example, 12 times 2 is not complete, right? Because in 7.1 I discussed I want prime factors to be as small as possible. Well, small as possible, I mean I only want to use prime numbers, and 12 is not a prime number here. 2 and 3 are. So this is a complete factorization, you could say, of 24a squared b. 11xy squared, well, 11 is a prime number, so we leave 11 there, and then we have x times y, because y is squared. Try this one for yourself, 8a to the power of 3. Start with the number. How would you factorize the number? And afterwards, how must I write a to the power of 3 in as many factors as possible? If you do this correctly, you will find 2 times 2 times 2 times a times a times a, right? Because 2 is a prime number and a to the power of 3 just means a 3 times itself. And we can make this as difficult as we want, right? We can use 21x squared yz to the power of 3. Start with the number, which is 3 times 7. And then write times x times y times z times z times z. Okay? Well, why do we need this? Well, first let's have a flashback to chapter 1.2, multiplying out the brackets. Yes, it's coming back yet again. We're going to use it a lot this chapter. And then we use this form. A times b plus c is the same as ab plus ac. And then we got exercises like this, right? 8 times a plus 2 is 8a plus 16. 4 3b plus 2c is 12b plus 8c, etc. Well, what we're going to do with factorizing is we're going to do this exactly the other way around. So simplifying x times x plus 7 is x squared plus 7x involves converting the product, something times each other, into a sum, something plus each other. And it won't surprise you maybe to say that this can work the other way around as well. So let's take a look. And that's what they mean with factorizing. Factorizing means writing as a product, which helps us a lot, as I already mentioned, when we're going to solve equations. So that's why we're going to do this. How do you do this? Well, let's say you start with x squared plus 7x, this one right here. What you're going to do is you're going to search for the common factors of x squared and 7x. Let's take a look at the box right here. If I rewrite x squared as a product, I can write it as x times x. And 7x becomes 7 times x. Now you're taking a look at which numbers or letters occur in both different factors. So here we have them in x squared, or I say factors, I mean terms. We have it in x squared right here, and in 7x we both have de letter x. So de common factor, de gemeenschappelijke factor, is x. Dat is het getal of de letter die in allebei die termen terugkomt. If I now want to factorize, or in Dutch we call this ontbinden in factoren. Als ik x² plus 7x wil gaan ontbinden in factoren, then I write down the number in front, which is the common factor, or the letter in this case. And inside the brackets I write down what was left. I have an x left here and I have a 7 left here. So x plus 7. I think it's a bit easier to show you how this works when not all information is given like this. So I'm going to continue to this slide, and here it's a bit easier to explain when not everything is already given. So the question here is factorize. Ontbinden in factoren. Rewrite this as a multiplication, right? As a product. 2ab minus b. The first thing that you're going to do is find the common factors of 2ab and b. So write down 2ab as 2 times a times b, and you could write down b as 1 times b. What is the common factor in this case? Well, that's the number or letter that occurs in both terms, which is only b. So you start with writing down the b in front of the brackets. What do I write inside of the brackets? Well, what I have left. Here I have left 2a, and here I have left 1. So now I write down b inside the brackets, 2a minus 1. Why minus? Well, because there was a minus here. If it was plus b, then I would have plus 1 here. Okay? Let's try it with 5x squared minus 2x. First, write down the common factors of both those terms. Oh, and by the way, you can also check it by going the other way around. You don't always have to do this, but now you can check that you've done this correctly. Let's go back to this one, right? 5x squared can be written as 5 times x, and 2x is 2 times x. So what is the common factor? Well, x, right? There was an x here and there's an x there. So how do I factorize? I put my common factor in front, only the x, and after that I am left with 5x and with 2. So I write down 5x minus 2. Okay? I will show you how this works in a bit more detail if you find this difficult in one of my elaborations as well. So please check that video if you're still not sure if you understand this example of how to factorize. The next part is about the remarkable product and about so-called difference of two squares, but I will discuss that part in the next video.